Okay, so today I'm going to talk a little bit more in depth about PV watts and a few things in the last video that I kind of glazed over. Those things being specifically the pitch of a roof, which also known as the tilt, so it's looking for it here. The azimuth of the roof as well, which I'm going to talk about exactly how to find that. And then just how to use the draw tool. So the draw tool is fairly intuitive, and that's what I'm going to start with. So again, we're going to go over here to PV watts. Yeah. Oh, okay, so basically, I'm going to use this roof plane as just an easy example. So simply what you want to do is find the direction that you think is going to be where your client wants the system. And again, as I mentioned in previous videos, if you think they want more than one surface, you're going to have to do this more than once. But so basically, you just want to pick the side that they want or the side that you want to start with, and just pick your roof points, like the roof corners. You're going to click, try to get as exact as you can. Actually, see right there, I kind of made a little mistake. I added an extra point, so I'm just going to reset that. Up, up. There we go. You should be able to move around a little bit. Yep, there we go. Boom, save. 4.1 kW, and that's assuming that the tilt is 20 degrees and the azimuth is 180. Now, unfortunately, I can't really find a good way to calculate tilt using Google Earth. If there is any trick, anybody has it, I'm all ears. With that said, there is a really good way to find azimuth. So to be specific, azimuth is the direction that the house is facing, which I kind of briefly touched on before. Now, there's ways you can do this. You can use Google Earth or Google Maps. I'm personally a fan of Google Earth Pro. It's just the desktop extension. It's still free, really easy to use. And basically, it just gives you a few more tools. So basically, as I talk about how easy it is and having trouble, there we go. All right, so if I want to find the azimuth, the direction that this is facing, Google Earth Pro has this tool. It's just the measure tool. It's a ruler. It gives you a bunch of different options, but basically you can click and so that is 139.77 degrees. I'd probably round that up and call it 140 degrees. And you can do this with any site. So for instance, so make sure you're right along the even point of the house. So 228 degrees. Fairly simple, fairly easy. Basically, an ideal solar site is around 180 degrees. Or actually it is exactly 180 degrees. It's true south. It's facing the sun. And again, ideally there won't be a ton of trees around it. But that's really a good simple way you can use to calculate the azimuth. Now, the tilt again is a little harder. You kind of have to estimate. So this is probably what we would call a 12-12 pitch, or maybe a 12-10. It might be a 40 degree. A 12-12 would be a 45 degree pitch. Very common, especially with new construction. However, they are typically pretty steep. You can't really walk on that type of thing. We do generally look for more shallow roof pitches just so that we can have the installers actually be able to walk and install it more quickly. With that said, you kind of have to estimate here, but regardless, so I'm going to estimate my roof surface here that I just looked at. I'm going to probably call that like a 28 or 30 degree pitch. It's just really a guess. You know, and we are going to do an on-site survey. So this is just again, for a preliminary estimate. It's not 1000% important to be totally accurate about it. It's just an estimate. But again, so I'm going to punch in my azimuth at 140. And we're going to call this, we'll round up. Cool. And there we go. Same information as we got before. But yeah, hopefully that little deeper detail in the drawing tool helped, and hopefully this video has been informative.